All right, guys, we're going to look at something called the law of sines, the law of sines. What it's for is to solve oblique triangles. Oblique triangles are triangles that are not right. Anything that's not right. We've solved right triangles using SOHCAHTOA before, and now we're going to solve something that's not right using the law of sines. It's useful especially when you know AAS, which stands for angle, angle, side. I hope you remember that from geometry. Angle, side, angle means the side is included in between two angles. Or side, side angle. Basically, you need to know this. An angle and a side opposite of that angle. If that's the case, you can use law of sines. Here's what the law of sines is. States that you can put the side and this over the sine of the angle opposite of that side, and it equals another side and the angle opposite that side, and equals the other side and the angle opposite that side. So A over sine A equals B over sine B equals C over sine C. And even if you turn those upside down, it still works. The reciprocals still work. So either way you want to go. But you must know a side and an opposite angle in order to use the law of sines, which we're about to check out on the next slide. Okay, quick example here. As quick as can be anyway. This one says in triangle EFG, it gives you the measurements what little e, big G are, solve the triangle. First of all, we make a drawing, which I already have up here for you. Now, because I know the two angles already, I can find the third angle just by subtracting those two angles from 180. So I'm looking at that 57 and 43 is 100, which means angle F up here must be 80 degrees. So I'm going to put an F. Where's my big F? There it is. 80 degrees from a big F. Now, that's an 80. Now, I'm going to try to find, what doesn't really matter. I'm going to try to find a little g first. So I'm going to use what I know. What I know the most of is I know angle E and side E because they're opposites. So I'm going to say 4.56, which is side E, over sine 43 degrees equals little g over sine 57 degrees. All right, now, to work that out, all I'm going to do is I'm going to cross multiply. I'm going to do 4.56 times sine of 57 and make sure I'm in the right mode here, which I am. And that gave me 3.82. So what I know right now, I'm at 3.82. I cross multiply. Now I'm going to divide by what's left. I'm dividing now by sine 43. Just working out a proportion. And I get this for G, 5.61. You want to punch it in your calculator, make sure. Basically what I did was this. I cross-multiplied this way, multiplied those two together, then divided by the sine 43 to give me the G. And I'm going to do that one more time because I still have to find my F down here. So to find F, I'm going to go the same thing, 4.56 over sine 43, that's what I know for sure, equals little f over sine 80, because this 80 is the angle opposite the f. You always go opposite. So when I start to work this out, I'm going to do the same thing. I'm multiplying 4.56 times sine 80, and I'm going to divide that by sine 43, which will give me 6.58 for my little f. And that's it. That's all I needed was my capital F, my little f, and my little g. And that's how it works. It's not that really complicated as far as working it out. Not that bad a deal. All right, there's one case that's bad, though, to be honest with you, and it's called the SSA case. Also, sometimes it's called the ambiguous case. I'm going to try to go through this with you. Before I get there, make sure you get this down right here. The height of these triangles, oblique triangles, are B sine A, and I'll be honest with you, that goes back to SOHCAHTOA, and I'll show you that if you're really curious about exactly where that comes from. I'll show that to you in class tomorrow if you really want to know. So here we go, all the cases. If angle B is acute and side B is not as long as side C, what happens is it's too short, which means there's no triangle. And these you're going to have to draw and find the height. If side B is shorter than side C and shorter than the height, if it's based on the height, if it's shorter than the height, it won't touch the third side, which means it's not even a triangle. Okay? There could be one solution if side B is exactly the same thing as the height. If it's exactly the height, then there's one solution. If B is less than C, if B is bigger than the height, it's all based on the height. If B is bigger than the height, then it's going to touch twice, which means you're going to have two solutions. Look at a couple more here. What if B, well, That's the same deal. It's based on the height. Everything's going to be based on the height. This book goes a little bit further than I like it to, but if you can find the height, then you can tell how many cases it has. Now, one piece of good news is if it's obtuse, if you've got an obtuse angle, you only have two possible cases. One is that the third side is too short. It's shorter than the height, which means there's no triangle. Or the other case is it is bigger than C, bigger than the other side. There's going to be one triangle. So obtuse isn't as bad. Obtuse is either going to have no solution or one solution. If it's acute, you could have 0 if it's less than the height, which was the first case right here. You could have one solution if it's exactly the height, or you could have 2 solutions if it's bigger than the height. And that's what's called, they call it the ambiguous case because there's so many options. So the best way to show you this is to show you one of each example and let you go from there. So let me show you one first of all that has no solution. So let me draw this for you real quick. Notice it gives me angle Q. So I'm going to try to draw this triangle right here. I'm going to try to draw triangle QRS real quickly for you. So if I draw angle Q here, which is 43.6 degrees, and R is 28, which is right here. R is 28. Which means what I'm going to do first, always, I'm going to try to find the height. The height, remember, earlier I told you was B sine A. Well, in this case, it's 28 sine of the angle. It's the side next to the angle times sine of that angle. So I'm going to try this and see what I get. I'm going to punch in my calculator, 28 times sine 43.6. And it gives me 19.3. So that means from here all the way down to this side right here, if I drew a line right there, the height, it's going to take me 19.3 to get down there. Well, side Q is just 15. So if I draw 15, I'm just going to get to about, about right there. I should change colors. About right there. I won't even go to the third side. And because I won't even get to the third side, that means there's no triangle, which means there's no solution. So that's all you have to do. It's all about that height. All about the height. Okay, this one has one solution. Let me show you how this one works. Draw the angle. Again, it says angle X is 39.7. So I'm going to put 39.7. Angle X. Side Y is 9.8. Okay, now I'm going to find the height here, which is, this case is going to be 9.8 times sine of 39.7 degrees. I'm going to punch that in. 9.8 times sine 39.7 degrees, and I get 6.25. Okay, now side X is 23.5. Now the only way that can happen, if I'm going to start from here and I'm going to go 23.5, I can't go this way because that's 9.8. The only way I can go 23.5, and also, by the way, the height's just 6 something. So if I went straight down here, I can't draw. There it goes. That's just like 6.25. So I've got to go 20 to get 23. I've got to go all the way out here. So this says 23.5, which is side X. This is angle Y. That's angle Z. And so that means there's one triangle. There's one case. And I'm going to solve it just like I did on the problem I was showing you earlier. I'm going to go use my X's because those are the two things I know. So I'm going to say 23.5 over sine 39.7 equals 9.8 over sine Y. And just punch it in. This is an angle, by the way, so be careful here. So what I'm going to punch in first, I'm doing 9.8 times sine 39.7. That gives me 6.25, which I did a second ago. Now divide that by 23.5. And what I have to do now, because I'm looking for an angle, I got to do my inverse sine. So I'm doing second sine of the last answer, and I get 15.4 degrees for my Y. So this angle right here is 15.4 degrees. So what I need now is I need my Z's. But here, I don't know either one of them, but one thing I do know, I know the angles have to be 180. So I'm going to take 180 and subtract out the 39.7 and the 15.4 and get 124.9. So my angle Z up here is 124.9. My decimal points aren't showing up. Okay, so I need to find side Z. So I'm going to take the same thing right here, 23.5 over sine 39.7, and use my z's. Little z over sine 124, I'm running room 0.9. All right, now cross multiply 23.5 times sine 124.9. Divide that by sine of 39.7. And I get 30.17. So side z, which is the biggest side because it's opposite the biggest angle, 30.2. All right, and there you have it. One solution. All right, two solutions. This is the doozy. You got to really stay with me on this one. This will be the longest slide we have left. Sorry about that. The next two slides will go much quicker. Hang in there. Okay, use what they give me. They said B is 29 degrees, so I'm going to go ahead and draw that. B is 29. There's B, 29 degrees. C is 20. This is A up here. I need to find the height. 20 times sine 29, just like I've done all day long. 20 times sine 29, punch it in. 20 times sine 29. And the height is 9.7. So the height is 9.7. If I go straight down from here, I'm going to go 9.7. That's right, there's 9.7. Just keep that in mind, 9.7. B, it says, is 15, which means B could do this. First of all, it's bigger than a 9.7. If I drew B straight down, it come to about here, which means if I swung it this way, it would hit there. That's a possibility. Or if I swung it this way, it would hit about there. So that's why there's two cases. It's a little bigger than the height, but it's not as big as the 20. So that means the B could be here. That could be B, or that could be B. Now, a couple things I want you to notice. If you look at the red triangle, if you just look at like BAB, which sounds weird, it's isosceles because you got both sides that are 15. So that means this angle and this angle are the same. So what I'm going to do is I'm going to find one of those, and that would also tell me what this angle is over here. So here's the triangles I'm trying to solve. Let me draw this out for you. I need to find this triangle. I'm trying to solve that triangle right there, that AB. I don't know why I drew B down there. I'm sorry about that. Those should have been C's. So sorry. Those should have been C's. I'm trying to find the blue one, and I also need, it's going to look weird, I also need this great big one, that big green one. So I'm trying to solve both of those. So I'm going to use what they gave me. I have 15 over sine 29. Those are the B's. Good night. Sorry about that. What's happening here? Sine 29, a marker, equals 20 over sine C. Now watch what I do here. I'm going to find big C. So the way I'm going to punch that in, I'm just telling you, you got to go through this on your calculator. I'm going 20 times sine 29, cross multiplying, divide that by 15, and I get a decimal. But I need big C, so I'm doing inverse sine, so I'm doing second sine of the last answer, and I get 40. I'm going to round to nearest degree. Let's say 40 degrees for C. Now, that's acute, which means that's this right here. That's that 40 degrees, which means that's 40 degrees, which means this other angle C right here, the other triangle, is 140 degrees because they have to add it to be 180. So I'm doing two cases. One C is 40, the other C is 140. Hope that makes sense to you. The big A, B is 29. So if I do 40 plus 29 and subtract it from 180, I'll get 111 right here. If I do 140 plus 29 subtracted from 180, I get 11. So there's my angle A's in each case. I probably should put case 2 over here, case 1 right there. So all I'm missing, all I need is little a. I need to find little a. So what I'm going to do, I'm going to do one more time. I'm going 15 over sine 29 equals little a over sine 111. That's going to give me little a. So I'm going to, again, cross multiply 15 times sine 111, divide that by sine 29, and I get 28.9. So I'm going to go 28.9 for little a. And then I'm going to do the same thing over here, using the same thing. 15 over sine 29 equals little a over sine 11, because in this triangle, a is just 11. So I'm going 15 times sine 11, divide that by sine 29, and I get 12.2. Guys, that's a lot. I know that's a lot. And just bear with me. I promise in class tomorrow, we'll work on this so much and it'll be so much better. Just trust me there. Please trust me, and we'll get through it, I promise you. All right, area of a triangle. You can find the area in a triangle as long as you know SAS, basically, two sides and the sine of the included angle. You can always do your area just like that. 1/2 BC sine A, 1/2 AB sine C, 1/2 AC sine B. The angle has to be between the two sides. Let me show you one real quick and we'll be done. There's a triangle. I don't know if you can see it in that picture. They want to know the area of it. And I have the sides 160, 170, 186. And I have this angle right here, 53. I hope you can see that. The angle is 53, and it's between the sides of 172 and 186. So, using the last formula, I can do this. 1/2 of the two sides times sine of the included angle. So I can do 1/2, 172 times 186 times sine of 53. And all you do is you punch that straight in. So my calculator steps, I'm going just like this. I'm going 0.5 times 172 times 186 times sine 53. Enter. And it gives me this 12,774.97. All right, feet. Square feet, because it's the area. Square feet. All right, that's all you got to do. Guys, I know that video is a little bit long. Law of sines has quite a bit to it. Not a hard skill, but quite a bit of stuff there. So we'll work on it like we always do, and we'll get it. Promise you, we're going to get this just fine. I'll see you tomorrow and we'll work on it.